2012 higher level DCG question B3. So 2012 marks the centenary of the sinking of the Titanic, the world's most famous ocean liner, which was built in Belfast. The image on the right shows the new Titanic signature building, which was opened in the city to commemorate the anniversary in April. The building incorporates planar faces which intersect as shown to represent the bow of the ill-fated ship. Figure B3 below shows the plan and elevation of a model of two such intersecting planes, ABCD and ABEF. The horizontal and vertical coordinates of the outer points of the two planes are also given. So we're given the points for each of the coordinates for each of the points there, except we're not given a height for C or E. So part A of this question is to draw the given plan of the two intersecting planes and locate points A, B, D and F in elevation. Part B is to determine the height h for points C and E and complete the elevation. Part C is to determine the dihedral angle between the two planes, and D is to determine and indicate the horizontal and vertical traces of the oblique plane that contains the surface ABEF. So on my page I have just set up an XY line, and I'm going to put my datum to the very left hand side of the page. I'm going to start locating all of my coordinates now. So point A has a horizontal or an X value of 165, an altitude of 0, so in elevation it's on the XY line, and a distance out from the vertical plane of 70 millimeters. Point B is 205 millimeters. With an altitude of 80. And a distance out of 110. C has a distance of 105. We're not given its altitude, so that's a height h, so it's going to be somewhere up along this line here, and a distance out from the vertical plane of 75, so that's the distance in plan, so that's point C. Point D is 120. Again, it's on the XY line, same as A, so that's D, and that has a distance out of 60 millimeters. That's D. E, 170. Again, we're not given an altitude for it. So it's going to be somewhere up along that line, and the distance down is, or out from the vertical plane, is 10 mil. That's E. And finally F is 155. It's on the ground, so that's F, and it has a distance out from the vertical plane of 25 millimeters. That is F here. So we'll join up all of the planes. A to B is common to both. B to E to F, and back to A. Now here A to D, B to C, to D. And again, locating the as much of this in elevation that we can. So A joins to B, and D will join to a point up there that we don't have. F will join to a point up here that we don't have, so I can't do any more up in the elevation. So draw the given plan of the two intersecting planes and locate A, B, D and F in the elevation. Part A of this question is now complete. Part B is to determine the height for points C and E and complete the elevation. to do that, what we're going to do is we're going to skip to part C of the question. That's determine the dihedral angle between the two planes. The reason we're doing that is A, B, E, and F are all on the same plane. So if we can find the dihedral angle, we'll find a point view, or we'll find an edge view of this plane. So we'll be able to extend our line on to find point E. So we're going to do the part C of this question first, the dihedral angle, before we do part B, and along the way we'll solve that. So same way we've done dihedral angle for everything else, we're going to look in perpendicular to it. So taking point B, projecting that out, point A, which is on the ground, that's point A, and we'll locate point B up here in a moment, and then D, E, F are all in line with each other here. So point D and F are here on the ground. This is point A, and we'll extend this line up here to find point B. So taking the height of point B, which we were given as 80 millimeters, you can mark that up here. This is point B. So I get the true length from here back to A. So that's the true length of the line AB. Looking along that point now will give me the dihedral angle between the two. So I'm going to take a point view of it. Find my x1, y1 line perpendicular to that. And I can also project out D and F. So out here we would be finding our dihedral angle. So to get our dihedral angle, we need to find the points in this view. So finding them up here, skipping this view, measuring from back here. Now the distance from here back is too big, and it's going to make things awkward. And also if we do point E as part of our measuring line, it's going to make it easy to it'll help us find the height of E when we need it in a moment. So I'm going to put my measuring line through here. So measuring line is parallel to the x1, y1 line, which is also parallel to the line AB in plan. By 2. So what we're going to do now is going to measure the distance from the measuring line back to the point. So it's the same for B as it is A. They're the same distance, so I can mark them up on their line AB up here. So this point here is the point AB. Do the same thing for F. F is this distance. So that's point F here. And point D is also, I can locate that one coming back this way. So this is point D. So I can locate the dihedral angle between these. F to D out here. That's the dihedral angle. Now I can use this to help me. I know that point E, so that's part C of the question done. Now we'll jump back to doing part B. So we know that point E is on the plane ABEF. So in my dihedral angle view, in my second auxiliary, that's going to appear as a point. It'll be a point on the same line as AB and F. As I set up my measuring line to be going through point E here is on the ground. In my second auxiliary, it's going to be on the x2, y2 line. So if I extend this point down here until it cuts the x2, y2 line, this point here is point E. So that point there is point E. I know point E is going to be out along here, along this line here somewhere. So in my auxiliary elevation, it's out along here somewhere. Where, I'm not 100% sure yet, but it is out along this line here somewhere. And when I was finding D and F out here, I took my points and I projected them out along this way. Same for A and B, I projected out along this way. So what I'm going to do now is I'm going to do it in reverse. I'm going to take the point from my second auxiliary and project them back in until it intersects this line coming from point E in plan. So if I project this back, where they intersect here, this is point E in the second auxiliary. And what I now have is I now have a height for point E in the elevation. This is H. You would be locating point F out here on the same way, point C out here the same way, but you don't need to, because it'll be in the same line coming back in along here. So where point E and C is, they'll both come back in here. So this is also point, so this is point C and E. So that gives me the height for C and E here. Just talking about that again. Point E is on the plane A, B, E, F. So it's on the plane. So if it's on the plane, when I have an edge view of the plane, point E is going to be on the same line as A, B, and F. So when I found my dihedral angle A, B, and F here, I found an edge view of that plane. Point E has to be somewhere on that line. So I'm going to extend my line down until it touches the X2, Y2 line. Why am I extending it down until it touches the X2, Y2 line is based on where I put my measuring line here. So I put my measuring line through point E, so I extended it down until it touches the X2, Y2 line. If I had kept my measuring line back here this far, I would have drawn in a line this distance above my X2, Y2 line, parallel to the X2, Y2 line, and where my line ABF extends on and intersects that line, it would give me the same thing. So if you put your measuring line out here somewhere, that's fine too. You'll just need to draw in another line here parallel to your X2, Y2 line, this distance away. Okay, so in the same way that F to there is that F to here, F to the measuring line is this distance, F to the other measuring line would have been that distance, so it would be back here somewhere. So you'd have a horizontal line or a line parallel to your X2, Y2 line, and again, it's where it's intersecting the line ABF. Gives me the point that I'm looking for. When I have that point, I'm projecting that back into my auxiliary elevation, which this is here. Projecting that back gives me point C and E, because it intersects the line coming from C and E in the plan. So with that, I can then draw. This is the rest of the plan here, or the auxiliary elevation, the rest of the plane completed. So now that I have the height from my auxiliary elevation, I can take that height and I can mark that in my elevation, in my principal elevation. So taking this height, this is the height CE. So from CE, this is the height. I'm going to mark that back up here. Why am I able to do that? I was able to take the height from B from my elevation and put it into the auxiliary. So it's going to work the same in reverse, taking the height from the auxiliary, putting it into the main elevation. So this is point C, and point E is going to be this one here. So now with that, I can draw in, I can complete the elevation, I can complete part B. This is point C, and F here to E is hidden detail. It's so this is point E, point C, and the height we have taken from the auxiliary elevation. Now, an alternative method of finding this height, if you look at the state exam solution, they'll show you this way. So they're taking an edge view of the plane here. So same idea as kind of what we were doing up here, taking an edge view of the plane down here. So I'm just going to do that one to show you this method. So taking edge view of this plane, so looking along the only true length line that we have, which is the line on the ground. So A to D here is on the ground, so if it's horizontal in the elevation, it's true length and plan. So looking along that here, projecting out point C and point B. So this is point AD, it's on the ground. And I can then take the height for B. So again, this is working off the assumption that I don't have the height for C yet. Taking the height for B there, marking that up. So this is height B. Joining AD to B. And where that intersects the line coming out from C gives me point C, and then gives me the height for point C, which works out to be the same. So in this method of doing it, which means you're not skipping different parts of the question, you're looking along this line here. The line AD it's a true length. It's horizontal in the elevation, which means it's a true length in plan. Looking along that line, so we're getting an edge view of the plane ABCD. Projecting that out along. Point AD is on the ground on our x1, y1 line. We have the altitude for point B, so we're measuring that up. That gives me this point. Drawing a straight line between the two, which is the edge view of the plane ABCD, where the edge view intersects the line that we projected out from point C, also gives me the height h. So you can do it either way. Both heights are the same. Final part of this question, part D, is to determine and indicate the horizontal and vertical traces of the oblique plane that contains the surface ABEF. So ABEF is this plane here on the right. We need to find the traces for that plane. So the traces are where this particular plane, if extended, would intersect the horizontal plane and the vertical plane. So first off, we need to remember that A and F are 2 points on that plane, and they're sitting on the ground. They're sitting on the horizontal plane. So if they're sitting on the horizontal plane, the line AB is part of that trace. So to find the trace here, if I extend the line through AF, this green line is the horizontal trace for the plane ABEF. To get the vertical trace, we're going to take a line parallel to that from any one of the points B or E, it doesn't matter. So I'm going to take it from B. So from point B, taking a line parallel to the trace that I've just found. So this line here is parallel to the green line. So I'm basically taking a horizontal cutting plane through that plane, projecting that up into the elevation, and then again redrawing this horizontal line. So this is a horizontal line in the elevation. It's a horizontal cut through that plane. That gives me this one. Going horizontal, so drawing what that looks like in the elevation. It's a horizontal line up here. That's the point on the vertical plane that we're looking for. So this line here is the vertical trace. And that completes the 2012 higher level question B3.